All right, so we'll start. So everybody was able to get something sent to me by now, or is that true? You guys were? Okay. So I just kind of have here, I just made a little scratch pad for me to follow along with. This was the function that um, I thought looked nice, so I plotted it. I did a little call out, meaningless call out. But yeah, if you did something similar, that would be pretty good. Um, do you guys have questions on how to now turn that in? I guess how did we? So Brady, you were able to now submit the
As a
PDF. Okay, that works. You could also submit the actual notebook file if you have it, I guess. So if you went to like your Mathematica files on the website, you might be able to just download the notebook. I'm not sure about that, but I think you can. And then you could actually just attach the file if for some reason you wanted me to edit it or you needed help with a part of it. I don't know if there's like collaborate, like a Google Doc, how multiple people can access it from the cloud at the same time. I bet there is.
There is, 'cause I'm
Yeah.
gonna share it with you. Give
By
you
these
access.
days, there should be that. And then did you submit as a PDF or
I submitted it as a screenshot.
as a screenshot? Okay, I'll take that today. That's fine. In the future, though, yeah, a PDF. So, are you on your laptop right now?
Yep.
If you would go to File, maybe is that how you did it, Brady?
No, I did prints and I was able to. See
Okay,
the PDF.
so if there's like a print button or Command P, you and then choose the print to file option.
How do you save it? Save as PDF. Yeah, how do you save it again?
The cloud, it seemed like it was like I didn't see a save button. I guess it automatically saves. Is that what you guys experience?
Yeah, it all saves.
It just auto saves.
Okay.
And then you submitted a PDF, Charlotte. Is that true or no?
Submitted the notebook file.
Okay. Okay. Nice. How did you find that on your laptop?
Get the name in.
I pressed file and then download.
Get the name
Nice.
in.
Okay. You have to name the file and then you can save it. Okay. All right. Very good. Hopefully, did you guys have questions about that? No?
It's resubmitted.
Okay. Awesome. Very nice. Okay, so what do I have here? Okay, yeah, in the Google Classroom, hopefully you guys can submit it. I forgot that I posted the homework already. So I did it a second time this morning, just because I forgot I already made a post. This one's a little bit more filled out though. I've linked it to the recording of the last class, so if you had to re-watch that for any reason. I will go back when I have time and make chapters so that have you seen that in YouTube videos how they have chapters and each chapter has a sort of description and so you know what each part is covering. I will try to do that in the future. Yesterday I just didn't have a lot of time. But you can also see the post there where there's the recordings playlist. And if you go there, I will have on my YouTube channel different, a whole collection of all the videos for this class. All right, so let's get started. We are going to kind of continue what we were doing last class and build on that. All right, so I'm going to make a new notebook here. I'm going to call this one class 5, I guess. So I'll save it already. And yeah, I realized when Brady said there's a zoom in the upper right, I thought he meant this magnifying glass, but I see actually a 100% right here. So now I don't have to like always mess with the, changing the font size. So I can just leave it and it will be bigger already. Is that okay? Can you guys see that all right when I typed? Is that good? Okay. So there's a few things I want to go over today. So I want to show you how you can plot multiple functions. That's what we'll do first. That was my intention for your first assignment, but we just didn't get there. So we will do that today. So let's start with plot. And it's a function, so I got to put something in the square brackets. Again, we need at least 2 things in here. The second thing is going to be the range, the domain that I want to graph over. So I'm going to go from -5 to 5. And then the front part is where I put a function. Does anybody have a function that they want to see to start out with?
3 and -2.
3 and negative, or a function, so not just a point, but like
Y,
x squared.
Y, comma, is the Y going to be by itself?
Oh yeah, y equals something with an x.
Y equals X. Oh, no.
Okay, we can just do x. So that's a line, right? That's a linear equation. It's just a line. You could do x squared. So I'm going to use Control 6 here to get the little nice exponent notation. That's my parabola, right? Do you guys know what x cubed looks like?
It's the, yeah.
Yeah. So remember, you always have one fewer bends than the degree. So if I have 1, like x to the first, just like x, no bends. Yeah, right. If I have x squared, degree 2, so I have 1 turnaround, right? 1 bend. X cubed, I should have 2 bends. Now it kind of doesn't look like 2 bends because this is the basic x cubed. But in general, a cubic, like if I had 2x cubed plus 5x squared minus 4x minus 1, like if I had all the descending degree terms, then you would see a more obvious separation between the bends. In this case, both the bends occur at 0, so it kind of looks like there's just like this single thing going on here. What if I want to, so let's do 2 functions. So all I have to do here is put a list where I put the function, so I need curly brackets there. And then I'm going to put a comma separating my function. So let's put in, let's say x. And now I can see the first function stays blue, the second function is orange. So like, it's always going to default to these colors. They're pretty nice colors, actually, the default colors. Like if I said to make it blue, if I typed the word blue, I think it's a less attractive blue. But the built-in default colors are pretty nice. I'll show you how to access those later today. But you can put more than that. So I could put in sine of x. That's a periodic function, so it kind of goes up and down forever. If I want to see that bigger, maybe I'll multiply sine of x by 3. I'll just put a 3 out front. What does that do? Before you type it, what do you think putting a 3 multiplying in front of sine of x is going to do to my function? You already did it?
Make it taller.
It makes it only taller, so it doesn't change where the zeros are. it doesn't change how many humps there are in a given range. It only stretches it out vertically. So now you can kind of see the hills and valleys here more clearly. Is that okay? Very good.
How'd you get that?
Hmm?
How'd you get that?
Are you not getting that?
Yeah, no, it just said use the plot called with one augment. Few augments are expected. I don't know what that means.
Arguments? So you just need a comma.
Okay.
So it thought that was all one expression. So it needs two parts. One is the domain where you want it to print out x value wise. And the first part is what you want to see plotted. Of course, we can add options. So I'm going to hit comma and press enter twice so that every option that I put in here I can see separately. What were some of the options? Do you guys remember from last class what were some of the options that we styled this thing with? Plot range. Very good. We'll go to plot range. What kind of plot range would you, do you remember what this does?
It puts like the arrows down.
No.
On the Y axis.
Yeah, it clips it vertically. Where do you want your window to show? So maybe I'll say -10 to 10. I need to put curly brackets, and I'll say -10, comma 10. And so now I'm zoomed in a little bit on the Y, so things look a little bit taller. Do you remember any of the other options that we used? Filling, very good. I like that one. Filling works nicely. I can say axis, and then it fills in between the curve and the x-axis. I could put in a number, like let's say 5. And now everything will get filled in between the curve and the line y equals 5. Not as nice looking, but could be useful. And then there was like a weird thing. I remember it with 2 functions. I don't know if it's going to work with 3 functions. Where they put the curly brackets, and then they say, I think it was 1 arrow, and then in another set of curly brackets, the 2, and that filled in between the first function and the second function. So it does between the curves. So maybe I could also do the third function to the second function. I don't know. I've never really done that. That seemed to work. Yeah, that's nice. So the second function is the orange one. And so now they're both shading the region between the first and the third curve to the second curve. Did that work for you guys? Are you guys following this? Okay. So one of the things I want to show you is some other things that we can do. I want to let's make another call out like we did before. So we can do that with epilogue, if you remember, spelled wonderfully. And then in curly brackets, I can put graphic primitives or things that I would feed into a graphics function to make it. So I can make a point at, and then I use curly brackets for a coordinate pair, 0, 0. And there's a little dot here. I don't know if you can see it. Do you guys see that? You see a tiny little dot? Right at the origin. It's kind of hard to see, right? Did everybody get the dot?
Yeah.
No?
It's not.
Yeah.
Is there a point size option?
There is, yeah. If you gotta put it in front of point. You can say point size, square brackets, and remember if they're like decimal values. Why is it not? Oh, you need a comma after filling. That's
Oh, yeah.
yeah. And then a comma after. You need the three.
That's the front part of it.
All right, yeah. So in front of the point, I could put point size, square brackets, and say 0.05. And that's a honker now. It's pretty big.
It's a big one.
We could. I really don't understand the sizing numbers and what those represent, but that's okay. If we don't want that, what you could do is, so a lot of times on like data graphs, like you circle the data so that you can see it more clearly. So maybe if I left the point, you don't have to leave the point, but I might leave the point small, and I might put circle here, and then the coordinates are going to be 0, 0. And then after that, I'm going to put a comma in circle to specify the radius. So if I just put in a 1 here, I'll get a unit circle. And it looks squished because you'll notice that my width of this window is 10, whereas the height of my window is 20. So, but it looks square, right? So things are actually squished in this graph. So this is a circle, but it is on a very squished coordinate system. Were you guys able to follow along?
Yep.
All right. So one thing I'm going to do is instead of a radius of 1, I'm going to go with a radius of maybe 0.1? Maybe 0.3, I don't know. There you go. It looks like Saturn or something. All right, and then I want it to be a circle. So I'm going to set a separate property. So put a comma at the end of that line, and let's go in here, and I'm going to say aspect ratio. I'm going to say 1. You can put a fraction here, and it's 1 to 1. I think it's height versus width. Normally things are width versus height, but that did not accomplish what I wanted it to accomplish. Maybe I have to say 1 to 2. No, 2 to 1, sorry. Now it's a circle. Okay, so I have to make an ugly looking box in order to correct my coordinate system. So I had to do 2 to 1 because there are twice as many ticks vertically as there are
I don't like the way it looks when the circle is
squished.
Yeah.
Yeah, I don't love this aspect ratio, so I'm going to delete that aspect ratio line that I just put in. And I'm just going to get rid of my circle. I'm going to just do point size again.
Size is the radius.
It doesn't seem to me, because I did 0.05.
It's only accurate for the y-axis, and it's 0.1 is 1.
Really?
Yeah.
We could read the documentation, but
I don't know why, but it's only accurate for the y-axis.
sometimes it's nice just to play around. All right, and of course we can add a color. So if you wanted to use those default colors, of course I could say pink. You know, I could use one of the named colors. I could do an RGB color function and specify a mixture of red, green, and blue. But you can access the built-in plotting colors if I type in color data with a capital D. And then inside here, I'm going to put two things. I'm going to put in quotes default Plot colors. Is that what I used? I forget how they're named. Default plot colors. Yeah. And then after the quote, I'm going to put comma 1, and that'll give me that blue. If I did comma 2, it would give me that orange. And if I did comma 3, it would give me the green. Did you have a question?
I did, yeah. So, over here, I made like Saturn almost. How do I make this work?
You in front of the circle, I'll show you. You can add. You can either just say thick, or you could say thin, or if you wanted to have a numerical value to it, you could type thickness, which is self as a function, and you can put in a number there. So you could put in like 0.02.
Oh, wow.
What did you put in?
102.
And it's huge.
Yeah, that was written.
Yeah, it's.
0.01.
Okay. Is this all making sense to you guys?
How would we color the actual lines?
The axes, you mean? What do you
Not
want?
the axes, like how would we color the functions?
Oh, you want different function colors?
Yeah.
So let's take a look at that. Does anybody remember how we colored the functions?
Yeah, you can
Function
put-
color.
Not function color. Color function was something that you could use with this option to make the rainbow. That's not. What was the option that we said? Do you remember? Did you guys color your functions on your graphs?
I did just now.
Colored in the axes.
Oh, you colored the axes? It's plot style.
Yeah.
Plot style.
So then I can put in a list of 3 different colors. So I could say red, green, blue, and these are gonna. I think these are ugly colors. Like they're just super saturated. So they actually look good on my monitor, but with the dark mode. But generally they're like 100% saturation. If you don't like those super saturated colors, you can specify with RGB color. I could say I want maybe 100% no red, 0.8 on green, and 0.9 on blue. And I get this sort of slightly desaturated cyan. It's pretty close to the original. So I used RGB color here, and I did some mixing. Is that okay?
Yeah.
You could also type RGB color, and then you see like, oh, it's a color chooser. So well, I'm not sure about the website, but it's built in this one. I could pull up this color chooser. I'm not going to do that. I believe you can do hex codes. So let's try 00 AA. Maybe I need to be in quotes. Pound 00 AA F EE. It doesn't know that that's a color, so I guess that doesn't work. I'll put green back here. I'm going to replace blue with. I hate how difficult this is, but this is a way that you can use hue, saturation, and lightness, which I kind of prefer. You have to say color interpreter. And then in square brackets, you're going to say structured color. And then you need another set of square brackets after that set of square brackets. And in quotes, you can type HSL. And in parentheses, you can specify a hue. So I'm going to do 200. Saturation, I'll say 80%. And lightness, I'll say 40%. and that gives me a type of blue-green here. So it's like, look at how long this was for me to create that. Like, it's kind of stupidly long. But that's how I can specify it with hue, saturation, and lightness, which is my preferred way of specifying a color. I wonder if structured color interpreter can also do, I'm going to copy that, and I'm going to replace the green, and I'm going to try whoops. I'm going to try to make a hex code. So what if I put in hex 00 AAEE? Yeah, that works. That kind of made the same color. I'll make it a different, not blue. So I'll do EEAA 22. And that gives me kind of an orange. So yeah, if you do this interpreter and you let it know you're about to give it a color, then it will accept different ways of specifying colors. I think RGB color is the only one that's kind of built in as a function. They really need to work on that. Because that's way too much typing for just picking a
So do
color.
we have to use that?
No, just if you want to get tight control over your colors, I think that's how you have to do it. Are you guys okay with this?
Yeah.
Questions?
Yeah.
Yeah.
Okay. Is it okay if we come over here?
Yeah, yeah.
Alright, so I'm trying to have, like I kind of made something like this on Desmos,
Mhm, I remember.
but I had like a half circle.
In front of the circle,
Yeah,
put dashed.
front of the circle.
Oh, you want it in front of the. Oh,
Like-
that's going to be harder to do.
Yeah, just kind of like this shape, but only the bottom. And
Yes, yeah.
that
We're gonna have to
kind
do
of
it like we did on Desmos, where we actually plot it as kind of like a function.
Yeah, never mind.
Yeah, it's gonna be a bit more involved.
Alright.
We can do it, but it's. Okay, any other questions?
Not really.
No? Okay, I want to create a call out. So let's, I'm going to come up here into my epilogue again. And I'm going to add two more things. We're going to add the arrow. And we're going to add text. And then I got to fill something into those. So after my point, I just added comma, arrow, square bracket, comma, text, square bracket. And then we're going to specify what we want inside of it.
So.
I
where'd
just,
you put it?
I added this stuff at the end of the epilogue list. So inside of that curly bracket. So epilogue, there was a curly bracket after the point, and right before that, I started typing comma, arrow, comma, text. It won't run yet, so we got to specify some things. So for text, maybe I'll say turkey, and I'm going to comma. I'm going to put a coordinate. Maybe I'll put this at 1,5. And now it's not happy about the arrow, but it is showing my turkey. It is picking up the color that I specified at the start of the epilogue. For the arrow, I need a list of 2 coordinates. So I'm putting in curly brackets with 2 curly brackets inside of that. So I can put in an XY pair here and an XY pair here. I want it to start just below the word turkey. So maybe I'll go to 1,4. I don't know. Comma 4, and I'm going to try to point to maybe where these 2 blue lines cross. That looks like they cross at 1.43. I'm using my mouse here to see. So like 1.45 and 3.1. Now it kind of points. I'm going to raise this up a bit, so 4.5. There you go. That's Turkey right there.
My arrow isn't showing up. How do you make sure it isn't just white real quick?
It shouldn't be white. It should be default. Not like if you're in light mode, it should be black. Unless you use the white color. Remember, okay, so arrow, you can't just put in 2 curly brackets with your XY pairs. You have to wrap that set of points in curly brackets itself. So it needs a list of points. There you go. Mhm. Delete that, and then just move it to the left one. The left. There. Put a curve up there. Is that it? There you go. Ah, and it's got your thickness, so it's a chunky arrow.
Cool.
Are we good? Anybody else need help?
Yeah.
You do?
Like, it says there's no closing, but even though there is a closing.
This epilogue needs a closer. That's looking better. There you go.
I don't know how to get the arrow in
Okay, you need a comma here. And then you need, the point needs to be in curly brackets, so there's a start and an end, right?
And
So
that's
I'm gonna do 2, 5 just to put something in, you can change it. But those have to be in a list themselves, so you need curly brackets around the pair.
It's confusing.
I know, it's something you just, you will eventually get used to it if you do it a bunch, but a lot of little rules. Okay, are you guys okay with this?
Yep.
All right, I want to show you guys some more stuff. Are you guys ready to move on from this particular graph?
Yeah.
Everybody satisfied?
Yeah.
Okay, so I'm going to come down below it and click down here, and let's make a section. So I'm going to go to cell style, and I'm going to choose section. So this isn't an entry, this is just a sort of divider. And I'm going to say transformations. Up here, I have a cell style.
Yeah.
Do you
That's
have-
supposed to command 4 on the website.
Command 4, yeah, that works too. Or up in format under somewhere under style. So if you go to format style, you can choose section, that also works. And then I'll click underneath that to make a new cell. So this is a section about transformations. Do you guys remember from Algebra 2 or from pre-calculus? What was I talking about when we talked about transformations? We talked about it quite a bit. What were some of our transformations that we used? Not all at once.
Were you just adjusting the positions on how?
Yeah,
they
yeah.
start, or just were they?
Sometimes we called that shifting it left to right, up and down. Sometimes we called that translations, right? Do you guys remember that? What were some of the other transformations that we could use?
Could change when it would actually start, just getting exponential
Oh.
or the cap.
Like adding to the x or
Yeah, that was, we called it translation or shifting it so we could move it.
Yep.
What were some of the other transformations we could do?
You could multiply it.
What did that do?
It would either expand it or stretch it.
Yeah, a stretch or a compression, dilation, yeah. We could also do reflections. And we could do rotations, though that's a more complicated transformation. So that's what we're going to do here. So let's define a function, and you guys can pick different functions. So I'm going to say f of x, and remember to do that, this is how we define a function. We have to say f square brackets, the variable has an underscore, and then colon equals. This will allow us to define a function that we're going to call f. Is that okay?
Yes.
All right. Let's pick a function. I'm going to pick x, let's say, to the 4th. Whoops, I did the wrong button there. X to the 4th, and then shift enter. That's my function. You got that? Now I'm going to say plot f of x, comma, x from -5 to 5.
In a different line?
What's that?
In a different line?
Yep, a different line. So x to the 4th is a degree 4 polynomial, which means it has 3 points where it can turn around at max, though. Because it's a very simple, x to the 4th is the most simple quartic, all of its turnarounds are together, bunched together at 0. So it looks like there's only one turnaround.
How'd you get that? Mine just doesn't show anything.
Did you do plot f of x underneath?
Yeah. Yeah.
You have to execute the top one.
I did.
You did a capital X.
Oh.
Yeah. So it thought that was a different variable that you didn't define. Do you guys all have your graph? All right, so what I'm going to do you got this, Isaac? I'm gonna wait till you guys are ready.
The line is not.
Problems? You got it?
Yep.
Good. All right, so we're going to now, so this is similar to when we added a slider for a variable in Desmos. So what we're going to do is wrap this whole plot function that we just made with the function called manipulate. So I put that all inside of manipulate. And then after that, I'm going to put a comma, and then I'm going to choose another range. So instead of changing x from -5 to 5 like I did with my plot, for manipulate I can choose another variable. I'm going to call it a. And I'm going to go from 0 to,
7.
there we go. Let's go from 0 to 7. If I want to move this thing left and right, or I guess in this case to the left, I'm going to put the plus a, do I put it on the x, or do I put it outside of the function? If I want left and right motion.
Put it
Yes. So I'm going to say plus A. So now A is unspecified, but it's going to start at 0. And manipulate allows me a slider, which I should be able to then play with. On the desktops, computers, if you were using those, you would have a smooth sliding action. On the laptop, it's kind of choppy.
I got a text box, right?
You got a text box? So I got this,
But I didn't.
and now I can, it's moving, but it's kind of changing my window, so we'll have to fix that.
I only got a text box.
Let me see. Oh, you need to close the plot there. Yep, and then get rid of one of those. So plot is inside of manipulate. Very good. So yeah, it's a little choppier on yours.
That's really cool.
You guys got it? That's cool. Okay, so in my plot, I'm going to have to specify the plot range so that I kind of stabilize my window. So inside of the plot, so after this X domain, I'm going to say plot range, and I'm going to lock it in from, let's say, -5 to 10. And now my window should be stable. So when I play with my slider, I can just move this guy around.
Whoa.
Were you able to do that?
Something up. Fine.
Let me do some line breaks, so maybe that'll help you guys. So I manipulate. Oh, filer.
Oh.
We have a drill. You guys know to go out there? Okay. Do you guys have this working, or do you need more time to type?
I didn't even figure it out.
Oh, I was doing line breaks.
That's fine.
Something wrong? Okay, I can come around. So manipulate has square brackets around the whole thing. Plot
I did do it.
takes a function, the domain, and then I put in the plot range to stabilize the window. Manipulate has, so that you got to close the square bracket on plot, and then after that there's a sort of domain for the variable that you want to manipulate. Is yours okay? You got it?
I'm going to close the bracket on plot.
I'll try to remember to do more line breaks to make it more clear. Are you guys both good? All right. All right, we're gonna add in the other 4. Well, I guess, so for this one, I can say, I forget how you get it to start at a value, but let's say, let's do A from -7 to 7. The problem with that is that it starts at -7, so it's off my screen. But now I can, whoosh, I can move it around, and so I can go to negatives or positives for A. So I can add or subtract from X, basically. And I can translate it left and right.
It didn't work.
Didn't it work? Let me take a look.
I tried copying like you did, but I can't because you don't have this.
Oh, yeah, get rid of that. Put a comma. Nope. Right, yeah. And then put a closed square after that, right, yeah. There you go. So the plot range
No.
is an option of plot.
In an hour.
You can't have an open square bracket for plot. Oh wait, no, yeah, you need the word manipulate. That somehow. Oh wait,
You're just connected.
let me see here. Here. There you go. I don't. So I guess when you type manipulate, you can't have a spacing before this opening square bracket, maybe? I don't know. Let me see here. I'm going to try something. So now, it starts at -7. And if I bring it into positive values, it moves to the left. If it's negative values, it's to the right. I think if I put the A itself in this little range here from -7 to 7, if I wrap the A in curly brackets and put a comma 0, I think that tells it to start at 0. So yeah, it does. So I can specify the starting value, and then the slider goes from -7 to 7. I remember that from many years ago. Okay. Now I am going to. Now we added this A. We put plus A.
How did you get that to work?
I wrapped the A itself in curly brackets, and then I put a comma 0 in there. That says A will go from -7 to 7, but start at 0. So when I execute it, it's sitting at 0, and my slider's in the middle.
I didn't get a slider, but I got a -7 and 7 button.
So it just starts at 0.
Those go on the red. Yeah.
Okay, we're going to add, so before we added A inside the function to where X was, right? This time if I add B outside of the function, so you see that? I added B right here. Then I'm going to create another range for B. So I'm going to say B comma -7 comma 7. And again, I want B to start at 0, so I'm going to wrap that in curlies and put a comma 0 in there. So now I have two sliders. I can move it left and right, and I can move it up and down. Is that okay? Let's get that. I added B, and I added controls for B. I just said it a bunch of times. I added B, and then I added controls for B. Did that work for you guys?
Still trying to
Oh,
You got it? Charlotte? Isaac?
Yeah.
You good? Okay. We're going to add now two more variables for the vertical stretch and compress and the horizontal stretch and compress. So if I want to do the vertical stretch and compress, what should I do to my function? Outside the function, yeah. So I'm gonna call it V. I'm gonna put a V out here, and then I'll just copy the controls for B with the comma, and I will duplicate that. And then I can create a control for V. Now the thing is though, if I multiply by 0, I'm going to kill the whole thing. So the starting value should be a 1 here. And we're going to go from, I don't know, let's say 1/10 to, or let's do 1/5 to 5. So I can divide by 5 or multiply by 5. So I have a V in front of my function here with a space. And then I copied the B controls and modified it. So this will be our vertical knob. If that works for you, you should now be able to make it taller, which makes it look like it's getting skinnier. Or you can make it stubbier, which looks like it's getting wider.
Can you go back up to
Do you have a V out front here?
yeah.
All right, let me take a look.
Oh.
There you go. Yeah, we gotta get you guys on the desktop so that it's buttery smooth. All right, we have one more thing to add. That's going to be the horizontal stretch and compress. It's going to look the same, but it'll be more.
Is that like a diagonal?
We'll get to that. That's a little bit more complicated. So I want to now put a multiplier on the x, but I want to not affect the x plus a, so I'm going to wrap x plus a in parentheses, just regular parentheses. And in front of the x, in front of the parenthesis, I'm going to put an h. And h will stand for my horizontal slider. So wrap the x plus a with parentheses and add an h variable for our horizontal stretch and compress. It's going to make it look skinny or wider, just like the other one, only because it's in with the x and we have x to the 4th. It's going to be, it's going to respond more quickly to changes. So the other one I was just putting a multiplier. This one is the multiplier to the 4th, so it's going to be more reactive. So I'm going to copy the controls for x, I'm sorry, for v, and just change that to an h. And now I have the ability to stretch and compress it horizontally.
So is H just a more intense V?
Basically. So if you think about it, this is my function up here. Do you see that? X to the 4th. When I put V in front, I just have a number multiplying it. But when I put H inside with the X, it's still a number in front multiplying it, but it's getting raised to the 4th power. So it's just, when I make a 2 out front for V, I double. but when I make a 2 in with the x, it's 16. So it reacts more quickly. So it looks the same, but one we consider the horizontal action and one we consider a vertical action. It has the same look. But you'll notice when I play with this now that when I increase V, it gets skinnier, right? When I increase H, it also gets skinnier. If I increase A, it moves to the negative direction. If I increase B, it moves to the positive direction. So this is transformations. We can change our functions. So instead of x to the fourth, you can reevaluate that. So I could say sine of x. And I now can play with this guy. I just changed f of x. I redefined it. And now this will let me move it left and right, move it up and down, stretch it vertically. Now there's a difference, right? Now I stretch it vertically or horizontally.
What was the sign?
Oh, just sine of x. If I put an x multiplying in front, I could get a little kind of wavy thing. Maybe I'll put a fraction in front, like 1/10. So now I get some weird looking guy. And bring it in. I put an x multiplying the sign, and then it was too tall, so I divided everything by 10, like this. So these are the transformations that we studied in last year.
Just how we forget those. What? Just how we forget transformations. There's a point. There's a certain
I thought
point.
it was a line.
How do you multiply?
What are you trying to do? Oh, I just make a space and put an x.
Isn't that a variable x?
Yeah. So every spot on this graph is at a different x. Was this good? All right, let's do some more things. So let's come down here and let's make a new section. And I'm going to say solving equations. So how do we use this to solve our equations? So if you remember, are you guys following along?
Yes.
If you guys remember, we've spent a lot of time with looking at different ways to solve equations. So we're going to go over that with how we can do it with using this software, and kind of review some of the things that we went over in our algebra classes. Okay, so let's create a polynomial, and then let's see what that looks like. So I'm going to say, let's call this one g of x. So I'm going to make the function g of x. And we're going to make up a function, right? Let's just try 1/4. I'll do it like this. I'll do the control thing so you can see it like that. 1/4 x to the third. Whoops, I keep doing that wrong. X to the third, we'll say minus 1/2 x squared plus x minus 1. So that'll be my function. So this is a cubic. And we will see what that looks like. Plot g of x from -5 to 5. Maybe I'm going to change the half to a 2 because I want to see more bend. Not bad. Maybe I'll change this quarter to a half, but I just want to see if I can make it more interesting. No, I don't like that. I'll leave it a 4. Maybe we'll try from -15 to 15 for the plot range. No. Oh, I didn't run that, did I? We'll stay 5 to -5. Yeah, that's fine. Let's maybe instead of 2, I'll make it a 4. Whatever. If I do a 2 here, no. What if I do -5?
Yeah, you make it curve downwards.
I'm just playing with some of these numbers. I'll just leave that the way it was. Or was this a 1? What did I have here?
Not showing.
Yours isn't? Oh, you need an underscore after the x in your g of x, the first one.
Can't forget that underscore.
Hmm?
I wonder if it's try to lift just around all this over here.
You don't need it, but we're gonna run that. You might be, you're getting a different plot range, so it's choosing a different, like, vertical x, like, you're going from like -50 to 30. Mine is different. So yeah, let's set the plot range so that we're seeing the same thing.
You have it going to the positive.
It will to the right. I guess we have slightly different numbers.
Numbers just missing from
-4 plus 2. I have a yeah. Why is? I don't know. I'm going to say plot range, and then we'll go from -100 to 50. That's what mine looks like. What is yours look like? Same thing?
These are two separate things. I accidentally ran this, so I had to run both instead of this.
Yes, yeah, you do. Otherwise it won't update. I'm going to what does this look like if we go -15 to 15? Yeah, there. Let's do -15 to 15, and let's do -200 to 100 for the plot range. There, now I can see a little bit more of my graph. So can you guys see the same thing?
No.
Yeah.
You do? You do?
No, I accidentally duplicated mine, so I'm trying to fix that first.
What do you mean duplicate?
I have two and I can't delete.
Oh,
this
you
out
can
with-
delete one, yeah.
Okay.
Sometimes that happens. It's like you select. It's
You
like
just drag down.
cells. Yeah, you select around the cell.
So yours is going like this.
Uh-huh.
Mine is just going.
Let's see. 1/4 x cubed minus. I have
Wait,
minus
did
4
you?
x squared. I've been playing with my numbers. Were you?
Yeah.
What's in that other tab?
What other? I have many tabs.
Okay. Go ahead and run. You have to execute that changed function and then rerun the plot. Otherwise it won't. Oh yeah, you got it.
Yay.
Very good.
So yeah. Just not that one part.
Okay, so we're solving equations. So imagine I had this function, right? And we want it to equal, let's say, let's make another function. I'm going to come in after this one, right in here. I'm going to say h of x colon equals. I need an underscore after that x. After, not before. And we're going to say what was that? 1/5 x squared minus 50. So that's now h of x. So h of x is 1/5 x squared minus 50. And I want to see it plotted, so I'm going to, instead of just g of x here, I'm going to make a list, and I'm going to add in h of x. And there is my other function. It's like a wide parabola. You guys got that?
Yeah.
Yeah.
Do you have it, Charlotte? Isaac?
Yep.
Okay. All right, so we're going to kind of review how we solve things in algebra class when we have polynomials that are on each side of our equation. So if I have this, do you see up here? If I had this polynomial for g set equal to h, how would I solve that? Well, what we would do in algebra is move all the like terms to the same side of the equation, combine like terms, and then we would have to try to factor it. So let me show you how that looks. So let's create. I'm going to copy this. Yeah. How do I want to do this? I guess let's copy these polynomials. So I'm going to copy that for g and paste it down below. And then I'm going to use 2 equal sign because I'm creating an equation. And I'm going to copy the other polynomial and paste it as the right-hand side. What's that? Yeah, a new cell, yeah. And I'm going to name this equation. I'm going to call it EQ. So equation equals this thing. And if I run it, you can see my equation. It kind of reformats it. It puts the powers in ascending order. But it's the same thing. You guys got that? I'm going to say EQ / simplify. I'm not sure what it will do, but I want to see it. And it has kind of simplified it. I don't really love that. Let me see what full simplify does. Same thing, I think. Pretty basic. I'm not sure how to write this in a different form. But anyway, I'm going to solve this equation. So I'm going to say solve EQ for x. And when I run it, looks like I get some cubed roots. I get 3 answers. And so one of them is at just shy of -3 to the left. This one's a little more than 4 1/4. I'm sorry, these are cubed roots of this. So, and then I get. Are you guys getting uglier expressions? You got the same as me?
Yeah, they're just not a pretty expression in a way.
What do you? Same thing.
Yeah, well,
What do you get? 2 equal signs. Oh, so yeah, you got that up there. So you can remove that. If that's saved properly, that's E2. Make sure you run that line. And then replace this entry with my line 70. Is that your laptop? Oh, you got a little fan. I was like, man, your computer's really hard.
I got all this.
Let's go up.
Well, I did, but,
Did you do a different function?
yeah.
Okay. So you have a very complicated function.
Yeah.
You might want to try the function that we're using or do something simpler. If you choose just like a parabola and a line that cross, you can do something simpler. You're going to follow the same procedure. All right, so one thing about these solutions that we get when we solve is we get what are called replacement rules. So x could be this, x could be this, or x could be this. Those are our solutions. You'll notice that it's not only a list, though. It's like there's curly brackets inside of the list. To get rid of that, you can just say flatten. I'm not typing very well today. So flatten will just make it so it's just one list, one set of curly brackets. And I'm going to save that as sols. So those are my solutions. That may not be good the way I put flatten in there, but I think it's okay. I may have to change that. So I got rid of the excess curly brackets. What I mean by a replacement rule is I can say, what is x when I do a replacement? So to do a replacement, you're going to do /dot, and I'm going to say sols. So use the replacement rules in this variable that I called sols, which is here, and show me what x is according to those rules. It only showed me 1. So I think what I have to do here is wrap this with, I can't do flatten, basically. That was a problem. So if I rerun that, sols is whatever the solution to this equation is. What is x when I apply those replacement rules? Well, I have 3 possible values of x.
Oh, how'd you only got 1?
Do you have a different equation?
Yeah.
Did you get rid of flatten?
Oh, no.
Yeah, that I can't set it equal to that with flatten applied to it. That was my mistake.
Oh, good.
Okay.
So what does that do exactly?
It gives us the x values of where these things are crossing. So now I can use the program to put dots exactly where my solutions are. So that it gives me my solutions to the equation. So where does function g equal function f? It's these intersections. So if I want those locations exactly, the software has given it to me. So now I can create some graphics, right?
But it's only giving, so is it supposed to be 2 numbers? And are the dots just like extra decimals?
No, this is like the cubed root of negative 2.95, so it's just showing me what my x values are. So let's create the graphics that I want. I'm going to say graphics. And then, remember, in graphics, I can give it points. So I'm actually going to create a list of points. I'm going to use table. And I'm going to choose to create XY pairs in my table. I'm going to say X, comma, And then because the functions are the same at those locations, it doesn't matter which one I use. I can either say, what is g at that x, or what is h at that x. I'm going to get the same y value because they meet there. So I can choose either one. I'm going to go with g. Table. Actually, you know, I don't think I need table. I think I can get rid of the table. Just do the point. But I'm going to apply the replacement rule. So I'm going to say sols. So I think that will create an ordered pair where x has been replaced with those solutions, and it'll create a list of 3 xy pairs. I believe that's what it'll do. No. Okay, so let me see what that does give me. So just, you can watch me for a second. I'm just going to paste this here and see what it does.
So the man didn't have a one box?
I think I need to do flat in here. Maybe that's the problem. No, I don't want to flatten it too much. So, So we're going to try table, I guess. Let me see. If I did table of this, so create a table of these pairs, but this time I'm going to x dot sols 1. I'm using double brackets, double square. Oh no, I want I.
Wait, what'd you copy and paste?
Let me test this, and then I will walk you through it. I comma 1 comma 3.
Those brackets are
I think that's it. Okay, so let me walk you through that. You know, we only have a few minutes. Is that correct?
yeah.
So why don't we save this and not, because this is going to be a while to walk through this. Just save it now, and we will come back to solving equations. Just save this document. I'm not going to give you a graph to make for today. These things are taking longer to demonstrate than I think they will when I'm doing it at home. And we will come back to this next class. Okay, so no homework today.
Yay!